Okay, so I will be explaining number 1 on homework 6, so 6.1 number 1, both parts A and B. For part A, it gives you the character equation here, and it says for what values of D could the system be stable. And you know that a system is stable when the roots of this equation in the form of S are less than 0. So as long as S is negative, the system will stable. And to figure that out, you would have to take the quadratic equation to find the roots of S. So using this equation, you come out with negative 6D plus or minus the square root of 6 squared minus 4 times 4 times 25D squared, making sure that you carry the D's with you. And it's all over 2 times 4. When solving this, you come out with S equals negative 3 over 4D plus or minus D times the radical of negative 91 over 4. I believe that in her solutions, the 3 and the negative 91 are not over 4, but I believe that they should be. So I will be doing them that way. And you can't leave a negative sign underneath the radical, so your final answer for S would be negative 3 over 4D, which is your real solution, plus or minus D over 4 times the radical of 91 times J. So this is your imaginary solution. So like I said before, S must be negative, but in that regards, you really only have to consider the real value. So you take S less than 0, so negative 3 over 4D has to be less than 0. And D can therefore be anything above 0, because if it was less than 0, negative times a negative, that would be above 0, obviously. So it has to be, D obviously has to be above 0. So that's your solution for A. And then for B, we're talking about decaying oscillations. And it says, is there a value for D for which the free response will consist of decaying oscillations? And you would figure this out by separating your imaginary solution and your real solution. And for decaying oscillations, your S obviously has to be less than 0, so that's indicated here. And then your imaginary can be anything except 0. So you set this equation, make sure it's not 0. And so D from this can be anything but 0. And from before, D has to be positive. So therefore, that is your solution. And so if D is greater than 0, the free response will consist of a decaying oscillation looking somewhat like the graph or the plot I have shown below.